Here is a video that's going to go over exercises number 6 and exercises number 10 as examples for you to take a look at. So example number 6 is very similar to example 1, so I'm going to go a little bit faster using both methods. So here is method number 1, long division. I want to go ahead and take x minus 7 divided by x minus 5. What times what is equal to x? What times x is equal to x? And that is 1. So x minus 5. Don't forget, long division, you need to subtract like all other divisions. So x minus x is 0. Negative 7 minus negative 5. If you get confused by negative signs, go ahead and write it out on the side. So negative 7 minus negative 5. This turns to positive, so this is negative 2. So I get negative 2 here. That is my remainder. So my overall solution is 1 minus 2 over x minus 5. Okay, so that's method 1. Now I'm going to go over method number 2, which is pattern matching. So method 2, I'm looking for a pattern. And I would like a x minus 5 on top because I have x minus 5 on the bottom. But to turn x minus 7 into x minus 5, I have to add something. And what do I have to add? I have to add negative 2. So x minus 5 minus 2 is equal to negative 7. That looks about right. Okay, so now I can go ahead and write this as two fractions. So x minus 5 divided by x minus 5 plus negative 2 over x minus 5. Now this first fraction turns out to be 1 because I'm taking the same thing divided by the same thing. So I can write this as 1 plus negative 2 over x minus 5. And you know this to be the same as 1 minus 2 over x minus 5. Okay, so I'm done. Two different methods. Now the question is, what transformations are here? If you remember back to the previous video, we have the general form a plus b over x minus c. Our a value is now 1, and that represents a shift up by 1. And that c represents a shift right, so I'm going to shift right by 5. And that 2 represents a vertical stretch, or a vertical scale by 2. Don't forget the negative. That negative tells me the graph has flipped. Okay, let's go ahead and take a look at the graphing portion. So here's my graph. Don't forget the general form. General form f of x is equal to 1 over x. That looks like this. So this is the graph we're trying to transform. So we need to take this graph, move it up by 1, move it to the right by 5, stretch it, and also flip it. So I'm going to go ahead and just draw in the asymptotes. So I need to shift up. So now my horizontal asymptote is here. I need to shift to the right by 5. 1, 2, 3, 4, 5. Make sure you give yourself enough room. I don't quite have enough room here, but I'll go ahead and change color so you can see better. And I have a vertical stretch and a flip. So instead of drawing it like this, my entire graph is going to be flipped. So that's why my graph is going to be on this side now. And this side. Okay. And that's it for exercise number 6. Now one more example, which is exercise number 10. I'm going to go over that one because it now includes a different general function. So here is exercise number 10 up here. I'm going to go ahead and copy it down here. So the function is f of x is equal to x squared minus 2x plus 3 over x minus 1 squared. Now I know this is going to be a transformation not of 1 over x, but this is going to be a transformation of f of x is equal to 1 over x squared, which hopefully you'll remember to have a general form that looks like this. And at this point, we're going to use both methods, but what you will see is that one method is actually easier than the other, and that's not necessarily always true, so you'll just know based on practice. So let's go ahead and walk through both of these methods. So method number 1, long division. I'm going to go ahead and just multiply this out. So the function is x squared minus 2x plus 3 divided by x squared minus 2x plus 1. So I need to do long division, so x squared minus 2x plus 3. In the denominator, x squared minus 2x plus 1. 1 multiplied by x squared is equal to x squared, and that's just 1. So go ahead and multiply that as 1 times x squared, 1 times negative 2x, 1 times 1. Don't forget to subtract all of this. So x squared minus x squared, 0, negative 2x minus negative 2x, that's also 0. 3 minus 1, and that is 2. So my remainder is 2. So that means my answer is 1 plus 2 over, I'm going to go ahead and rewrite this back as my x minus 1 squared. And that's only because it's easier to compare to this particular general equation. Okay, so that's my answer for long division. Now I'm going to go ahead and move down to my pattern matching method. So here is how I'm going to pattern match. Here's my original equation. And just like the part where we didn't have squared, I want this x minus 1 squared on top, but I need to add something to it to make it equal to this, so they're still equivalent expressions. So what do I need to add to this to make it equal to that? Well, let's go ahead and multiply that out again. So when I multiply out x minus 1 squared, you will get x squared minus 2x plus 1. So what do I need to add to x squared minus 2x plus 1 to get to 3? Or to get to x squared minus 2x plus 3? Well, the only difference is a difference of 2, so I need to add 2 here. Because 1 plus 2 is equal to 3. Okay, so with that, I can go ahead and rewrite this as 2 fractions. So this has 1 fraction, and this has another fraction. So I get x minus 1 squared divided by x minus 1 squared plus 2 over x minus 1 squared. As you can see, this part becomes just 1 because I'm taking the same thing divided by the same thing. So this is 1 plus 2 over x minus 1 squared. Okay, take a look. Long division, pattern matching, same answer. Okay, so now here's the hard part. Transformations. What transformations do we have here? So I didn't give you guys a general form, but as you can see, it's very similar to our form where this is just 1. So the general form is a plus b over x minus c, but this time we have it squared. But the transformations are the same. So taking a look at this equation, we have shifted up 1. So shift up 1. This tells us, the c value tells us this is shifted to the right by 1. And that 2 tells us we have a vertical stretch, which is hard to see when you graph it by paper, so that's okay. So here's my graph, and I'm going to shift up by 1, and I'm going to shift right by 1, so my asymptote is now here. And now, instead of my graph looking like this, my asymptotes have shifted, so I'm going to go ahead and just graph it in. The shape is the same, and here is my graph. Awesome, and there you are done. If you have any questions, make sure you email Ms. Tuan over the weekend or come after school to her office hours.